much for attending the webinar, Shallow Geothermal System Inventories as a Basis for Sustainable Utilization, organized by GeoEnergy Expert Group of the EuroGeoSurveys. Once again, thank you, Cornelia, for help in preparation. We are the two people in charge of communication in this group, and today we will have, oh, my slides are also not moving. Excellent.
We had some difficulties in the
Yes,
preparation phase.
Totally. Let me see. I would just like to show you also the list of today's presenters. So I will share this screen if I manage. I hope you can see it.
O, Karlo Borko jest na spotkaniu.
Sorry? Someone was waiting. So we will have 5 interesting presentations about shallow geothermal system inventories from different European countries. And we will start by Spain, or to be more precise, in Catalonia in Spain. I would like to ask Ignasi then to share his presentation.
Okay, thank you, Cornelia and Nastasa. I'm going to share my screen now. Please confirm when this is ready. It's okay?
Yes.
Can you see now?
Mm-hmm.
Okay. So thank you very much for having me. My name is Ignasi Herms and I work in the Geological Survey of Catalonia. The first thing that I want to introduce and highlight here is that regarding the webinar title, I will present the case of the Catalonia geothermal market, which is a technological mature market, I would say, but still facing huge challenge in the permitting and regulation, basically. We have several bottlenecks, such as the absence of an official registry. So I will explain the current situation in more detail during the presentation. So I have structured the presentation in 4 blocks. I will present first an overview of the shallow geothermal energy market in Catalonia. Then I will introduce the current legal framework that we have in Spain and in Catalonia. Then I will introduce what we call Shallow Geothermal Energy Observatory of Catalonia, which is it's different than what is called Observatory in UK. Here it's basically an inventory of installations. And finally, I will present some issues regarding the Catalan Geothermal Action Plan that we are drafting right now for the government, for our government. So just to contextualize, if we talk about the beginnings, the shallow geothermal energy in Catalonia began to be implemented in the early 2000 with some experimental and demonstration projects. In 2002, the first specific company dedicated to shallow geothermal energy was created, which was one of that implemented most of the facilities promoted in Catalonia in the beginnings. From then, other companies in the market, and this began to grow with new heat pumps providers, installers, engineering and consulting companies, and so on. And also from the years 2008 until 2012, the first medium and large facilities of the tertiary sector were implemented, like the 2 that you can see in the screen, with almost 3.6 megawatts, which is the largest closed loop system that we have right now in our territory. So the shallow sorry, from 2008, shallow geothermal energy in Catalonia began to grow progressively with more push. But in that moment, in Spain, also the market was growing, and for example, in 2010, it appeared the new Galician geothermal cluster is in Galicia, the northwest part of Spain, and that was created to promote the shallow geothermal energy. In Catalonia, we sought to do the same, and between 2011 and 2012, we also tried to create a geothermal cluster in Catalonia. However, this was finally abandoned, mainly due to the economic crisis. But it was actually in 2018 that in collaboration with our institute and the Association of Geologists in Catalonia, we consolidate the new geothermal working group inside the cluster of efficiency energy, which is a cluster that has companies that promote renewable energy in the broad sense. And we thought in that moment that it fits very well with the shallow geothermal energy because of because they look for energy efficiency in buildings, and the implementation of the renewables have self-consumption that links perfect with the possibility of hybridization with shallow geothermal energy. So you can see here a picture of the preparatory meeting held in our institute in 2018. Nowadays, there are more than 54 members in the geothermal working group on total within the cluster that it has 230 members. And this is still working and promoting the implementation of shallow geothermal energy in our territory. And if we see the type of shallow geothermal installation that we have in the public sector, we have different situations. For example, in town hall buildings, sport facilities, museums, universities, kindergartens, fire stations, police buildings, office buildings such as our second office. Also, we have several or few district heating and cooling systems fed by shallow geothermal energy, and another kind of buildings like these ones that you can see here in the screen. However, I would say the penetration of the geothermal energy in Catalonia from our point of view has several obstacles, several bottlenecks. The first one is that mainly the focus of the debate in the news mostly rely on power generation with solar photovoltaics, wind farms, self-consumption with photovoltaic panels, and the promotion of local energy communities with photovoltaics, the implementation of bioenergy with district heating systems fed by biomass, and the implementation of air source heat pumps, but not specifically on shallow geothermal energy. But one of the barriers that we have is in the market is the permitting process, the lack of official registering, and a clear and efficient procedure of the permitting for drilling. So as far as the legal framework, I have to say that in Spain there is no single or specific procedure for the processing of shallow geothermal energy installation, nor a unified official registry. Each region in Spain and in Catalonia has their own procedures and rules, which obviously creates an uncertainty and hinders the implementation in the market. So in general terms, depending on how open loop systems and closed loop systems are interpreted in each region, I would say that there are three main administrative steps or procedures to follow for permitting. The first, both ones would be before implementation. You have to take authorization for drilling. First of all, in the river basin administration. In Catalonia, for both open loop systems and closed loop systems, and also in the other hand for the mining authorities, because they consider that the drilling process is mining work according to the regulation of basic mining safety standards. Finally, when the installation is implemented, all the installation has to declare the thermal installation in the industry department, presenting all the documentation about the thermal system. So what we see, or what we saw as far as the weakness of the solar geothermal market in Catalonia was basically low visibility until at least 2018, because we didn't have an official register. So this means that we didn't have official statistics on the status of the implementation of the market until that moment. So that's why we decided, in collaboration with the cluster of energy efficiency of Catalonia, with the geothermal working group, to implement some kind of continuous updated inventory of installations, with the objective to have a first picture of how the market is progressing. So the information, the data that we collect mostly comes from the companies, the installers that are participating in that cluster. So with this information, we generate reports, fact sheets, and some kind of statistics like the ones that you can see in the picture. So how it works, this continuous updated inventory of installation, which is not official registry. So we, the Geological Survey of Catalonia, in collaboration with a cluster of energy efficiency, we collect the information of installations that are implemented in our territory, and then we process this information and we put all of this in a database. With this information, and using Power BI, which is a tool, one of the possible tools that we can use to elaborate some kind of reports, we create a dashboard that is embedded in our website with interactive dynamic tables, charts, and maps, and pipe charts, for example, with filtering capabilities that can be selected by geographic attributes or different data types, like the power capacity, the kind of scheme, if it's public or private installation. And this is the information that we can provide at this moment. So you can see here some of the pictures of the dashboard that we have in our website with the charts, the histograms. I will not go into detail with the data. And some of the maps, showing public installation separately, and a map of private installation aggregated by municipality, for example. And some fact sheets of each installation that we can have some information. So this is information that we collect as an inventory of installation. Okay. So as I mentioned, we maintain this inventory database of installation, but this is not official register. So that's why one of the reasons why in 2024 we agreed with Energy Institute of Catalonia, which is the entity that is in charge of promoting the implementation of renewable energies in our government. We agreed to draft our future Catalan Geothermal Action Plan. And this plan is organized in two parts. One is the diagnosis, and the second part is an action plan. And you can see here a screenshot of that appeared in the news in Catalan, sorry, highlighting this announcement. So one of the key action that we expect for this action plan is to create precisely one official registry, consolidate our observatory as a communication tool, try to get faster permits, reduction of the taxes, and create one stop shop window to proceed with all the permits. So this streamlining it's based on three pillars, as I said before. One is the creation of official register and consolidation of our communication tool, the observatory. Then we will try to accelerate the permitting process, going beyond what is established in that regulation, to accelerate the deployment of renewable energy, and also reduce the taxes, and also integrate all the steps for the permitting in one centralized access point for in one website to facilitate the implementation of the market. Here in this sketch, there is the concept of the future website where the permitting process will all the citizens will follow. And finally, just to comment about the market in Catalonia, we are seeing very, I would say, encouraging things that the market will grow in the future. But of course, we need to approve our strategy with our government to consolidate this growth, which is more or less 15% by year, which is not it's not a minor growth. But of course, the implementation of an official registry is one of the key pieces of this process. And that's all. Thank you very much.
Thank you very much, Ignasi. Oh, we already have one hand in the air. So, Telly, is that just for claps, or you wanted to ask a short question?
It was just for applause, just for claps. Thank you.
Okay, thank you. Yes, we will have time for discussion in the end. I suggest we now stick to the schedule. So I would like to give word to our next presenter, Professor Vladimir Soldo, who will present the experience of PLIGES project about creating a database in Croatia.
Thank you, Sasha. Could you see my presentation?
Yes.
Yes. Could you listing of my moving of my presentation?
Yes.
Okay, thank you. Good afternoon, ladies and gentlemen. I come in from the University of Zagreb, Faculty of Mechanical Engineering, and today I'm going to present the report, the title, the PLIGES Project Database of Shallow Geothermal Systems in Croatia. This is what I want to talk about today. In the first part, I will present our research in last 20 years. Here you can see the project what we have implemented in the field of heat pump. Most of them are shallow geothermal systems. At all of these projects we have implemented the pilot plants, demo system with real application and measurements. The peering project was started in 2007. It was our first research in this field in Croatia. In the premises of thermodynamic laboratory, we installed the borehole heat exchanger in the depth of 100 meters. It's W pipe heat exchanger together with borehole heat exchanger. Thermocouples, temperature sensors were placed along the borehole. It was the first measuring results of ground temperature. It's very interesting to check, and also here you can see some other results in this first research. In the scope of project, we designed the TRT unit. Here you can see in situ measurement on location IKEA Rugvica near Zagreb, and also you can check the thermal ground properties in the field of efficient thermal conductivity and thermal resistance. In 2013, we were granted by project IPA 3C. It's research and the promotion. It's project research and the promotion of use of shallow geothermal potential in Croatia. Our partner was Croatian Geological Survey. Stasha was the leader of geothermal team, and the main goal of the project was determination of ground thermal properties in 8 different geological regions of Croatia. We used the TRT method for the determining of thermal properties. There are differences between Pannonian region, its sediments, and Adriatic region, its carbonate rocks. Stasha is expert for this. It was the project obligation of her team. A lot of measurements have been collected, very valuable measurement who is used for designing and for research for many years. You can see the sum of these useful results. Also, in each of location, we have implemented the demo system. Here you can see the state of the art of our system at Faculty of Mechanical Engineering. It's amazing system. It was renovated during the renovation of university buildings for last 3 years. And 1 month ago, we started with a new measurement. And in cooling mode for last 30 days, efficiency is over 6. Over 6 is perfect. And a lot of measurements can be used for student education, for seminars, for research. Optic cables are placed along the borehole. A lot of sensors for measurement energy balances are used. The next project is cooperation with Italian consortium. We participated for demonstration of demo system at Technical Museum Nikola Tesla with 3 W pipe boreholes and borehole heat exchangers and 3 coaxial. It's a cascade high temperature heat pump. This is a result of Sea Adrian project with seawater as a heat source, together with partners from Italy, Slovenia, Albania, and Greece. We have participated and also implemented the free pilot plants, free real pilot plants for measurements. During the last 15-20 years, we have discussed the possibility of review of installed system, overview of installed systems. We have checked some other countries, but it haven't been implemented up to 2023, when we granted by EEA project supported by Iceland, Liechtenstein, Norway fund. It's project mapping of shallow geothermal systems in Croatia. The lead partner is my institution, University of Zagreb, Faculty of Mechanical Engineering, and 2 other partners are Faculty of Mining, Geology and Petroleum Engineering, and private company TT Engineering. The main goals were creation of shallow geothermal energy database estimation of energy production of shallow geothermal systems, development of interactive GEES map, and increasing capacity for future application, for new application of new systems. As I mentioned, as I stressed, the strong team was created. The leader of team from Faculty of Mining is Professor Tomislav Kurevia. The leader of team from private company TT Engineering is Goran Tomeng, and our team was led by me from Faculty of Mechanical Engineering. Our experience for last 20 years it was useful components for successful implementation of this project. During the screening of installed systems, we have contacted many system designers, installers, drilling companies, Croatian Heat Pump Association, some other government bodies, and so on. And we used the questionnaire with a lot of parameters regarding heating capacity, type of shallow system, year operation, temperature regime, type of emitters, location, and so on. We have visited a lot of sites from Dubrovnik, from south to north area to east area, and here you can see some site visit of project team. We can point out a lot of very good practice of these geothermal systems. Here you can see some of seawater heat pumps at Zadar, Dubrovnik, Rovinj, and so on. Regarding the ground source heat pump with a closed loop, the largest system is in east part of Croatia. It's Hotel Matera in Čepin with approximately with near 90 vertical borehole heat exchanger and total length of 8,700 meters. In the neighbor of this building now, it is implementing the one more system. It will be near 100 borehole heat exchanger. Here on the right side, you can see water source heat pump at American International School of Zagreb. It's interesting to check the temperature of underground water, because a lot of demands are for cooling, and it is very important to check this temperature, because it can be used for passive cooling also. This is building of our university building, Faculty of Mechanical Engineering. Last 2 years, these buildings have been renovated. Also, the system, heating system, was recovered, and new water source heat pump system was applied, also together with PV plant, and it's very good practice of energy transition, especially because it is used for education of students, of stakeholders, and it will be very interesting for the research. Also, I would like to point out that the percent of closed loop and open loop is very similar. Approximately 50% is closed loop and 50% is open loop ground source heat pump systems. Together with database, we have created the GEES map. It can be selected with different parameters, aggregation of database parameters regarding capacity, type of heat exchange, depth of wells, and so on. And it is updated from day to day, and with registration some other designers, planners, installers could update the data in this GIS map. During the project, we have organized 2 project workshops, 1 roundtable. All materials can be downloaded from our website. Also, dissemination of results is very important on different conferences, roundtable, and journals. Results have been presented. The main project results is over 200 ground source heat pump systems. Estimation of geothermal energy per year is 70 gigawatts. Annual reduction in CO2 is to 12,000 tons. And also, a project team has published the brochure regarding the designing, planning, installation, and maintenance of shallow geothermal systems. And for conclusion, it's support. This project is support for creation of public available database. It's used for promotion of technology, direct contribution to a larger utilization of this technology, but also we can screen some weaknesses regarding the development of skilled drillers, planners, installers. Also, we would point out that it's very important to government support in this field, because regarding the results what I have presented, the potential is large for this technology. Thank you for your attention.
Thank you very much, Vlado. Do we have some immediate question for Vlado? Okay, thank you. Then we will proceed to the...
I would have one actually.
Sorry, I didn't see your hand. Yes, please.
So is there any how is the database updated? Is there any obligation of companies to include data in the Croatian database now, or how is this handled in the future?
It's open database, and with registration, it could be updated from each of stakeholders. In the registered database now we have approximately 30 from different fields, and in common there are installers and drillers of boreholes or wells.
Okay, thank you.
You're welcome.
Thank you very much. Then let's proceed to our next presenter, Erik Simmelink from the TNO of the Netherlands. So we will move a little bit to north this time. Please, if you can share the presentation.
Yes, I'll do my best. See what happens here.
Great, it's there.
It's going all right, I guess so.
Yes.
Yeah. So also from my side, thank you very much, Stada and Cornelia, for getting the opportunity to tell something about the Dutch registry of the thermal energy storage systems. Because maybe in contrary to other countries in the Netherlands, shallow geothermal energy actually consists of ATES and ground source systems, so open and closed systems of storage. I work at the Geological Survey, have a function as information manager groundwater. So I'm working on data streams and data flows rather than having expertise on the projects and the systems itself. What I would like to address in this quarter is the need for a legal framework as already was mentioned also by our former presenters, which is being which was installed in the Netherlands as a key registry of the subsurface. And this is really, and we are experiencing that in the Netherlands, really a catalyst for getting actual and high quality data in a central database. To start off with, to give an example, last Saturday I made a stroll in the neighborhood of my mother's nursery home where she lives, and I encountered a freshly and newly drilled well, what seemed to be a well of an ATIS system. So I started wondering, was curious, is this well already available in our portal, in our database, in our registry of the key registry of the subsurface? So I went into the portal that we are maintaining for the Ministry of Space as a geological survey. We are hosting the whole system, and we're hosting also the portals in that. And look into the area where I was walking in the neighborhood of Zwolle in the eastern part of the Netherlands, and zoomed in, and to my glad surprise, I saw the system coming up. And when I looked into the data on the system, I saw that it was from the data owner, the provinces of Rijssel, as an authority. They are responsible for registering the data in our registry. That it is, well, it was quite recently that they registered, end of June, so a week ago, and that the lifespan started in May in this year. So it's really a very recent system that is in the database. The database and the portal also gives the opportunity to download the data behind the whole system in an XML file. And if you put that into some kind of area in functionality where you can read this XML data, for instance, in Excel, then you could see the license information of the province, seeing that it was an ATIS system, and get some idea on the parameters of the system with maximum flow rates, the power parameters, and could see that it exists of 2 wells with a stream depth and a bottom depth of 110 to 155 meters. So that was all available in the same afternoon, Saturday morning or Saturday afternoon, that I encountered this well. And the hydrogeologist in me, what made me curious also, in what hydrogeological aquifer is this then being drilled? And this also is in our registry. We have not only data, but also model data of the subsurface in the Netherlands. And with this data, the base of these models, you can draw cross sections. And if you draw a cross section around over the area where I found the well, then it gives me a cross section. And then you can see that around this depth and the depth of the screens, that's lying under a clay layer, which is depicted here. So this is more or less the depth that this ATIM system is being installed at the moment. This all gives the information within an hour after I finished my, or a few seconds after I finished my stroll, going towards the internet and going towards the public portal. So what the success story about this data being available in a database, in a central database like we have in the Netherlands. And that's something that I would like to explain something more, and that's a sort of 2 type of acts, central from the central government, together with a non-compulsory registration that was there before in the National Groundwater Register. It's the Environmental and Planning Act and the Key Registry Act of the Subsurface Act, which is also well, now present in the Netherlands for 5 years, more than 5 years, 7 years. We'll address the various aspects of these acts a little bit. Firstly, the Environmental and Planning Act regulates really the permitting authorities. The ATEMS systems are under control by the provinces in the Netherlands. We have 12 provinces in the Netherlands. And they are granting the permits for the ATES systems, or the open systems, whereas in the degree of the environmental activities underlying in this act, the municipalities are held responsible for the closed loop systems, the ground source heat systems. And there's a notification or reporting required by the initiators. And this also regulates that for a proper assessment and granting and supervision by the authorities, that there's a sort of compulsory provision of a data set that has to be handed over by the initiator or owner towards these authorities. In the moment of application, design figures and design parameters, and also during the development and exploitation, so that they can supervise the aspects of the systems. And I put standard in brackets because there's something let's say what was initiated in this Environmental Act, which wasn't 100%, and on top of this act in terms of the Environmental and Planning Act, the Key Registry Act improved that. So the various permit applications go in local permit application portals and in local management system of the various authorities. And that's then, say, the responsibility of the authority, the local authority or province authority. And in 2013, there was already a groundwater extraction register. And in 2013, it was decided that also the data coming from the ATES and ground source expert systems should go in this National Groundwater Register. So the various data coming from the various local authorities were registered in this National Groundwater Register, which then also this realized that there was a potential portal being made for ATES and ground source heat pump systems based on and making use of the data in this National Groundwater Register. The weak point, as far as that was concerned, was that there was no obligation of handing over, registering these local data towards this National Groundwater Register. So it worked, but it was not complete, and the actuality was, so to speak, was not very complete. So in the next phase, the idea of registering subsurface data led to the implementation of this Key Registry Act as of 2022. Valid for the groundwater use data and also the shallow geothermal systems. The motto behind this
Sorry, Erik. We are having we don't hear you very well. It is like intermittent sound.
Sorry?
Maybe you your sound is intermittent. Maybe you moved from the microphone or something.
Okay, then I will get a little bit closer to the microphone. Yeah, sorry. So the Key Registry Service Act has a motto, and it's broader than only the systems of the data of the shallow heat systems. It tries to bring the vital subsurface information towards the governments and towards the local society on a transparent way. So of this BRO, the Key Registry is in Dutch BRO, it has several data domains, not only these groundwater use data and ATES systems, but also compenetration test data, borehole investigation data, groundwater monitoring data, so groundwater quality level, groundwater quality data and groundwater level data, and also the subsurface models, like I showed as a hydrogeological model that I showed in the cross section. And since this year, Also, environmental quality, site-specific environmental quality data are a part of this key registry that we're having. So the ATIS and ground source heat pump systems are sitting in this ground use part and domain. And the idea is that there's a legal obligation of data delivery towards this key registry, and governmental bodies are accountable for the data reliability, and that really reinforces the quality of the data, because it's called really an authentic data. And we also are imposing data and exchange standards to have an efficient reuse of data, and everyone knows what the data are about. And this really, that's why the chameleon is there. This really is has started a sort of cultural change in how to handle data, how to store the data in all kinds of local authorities. All the provinces, water boards, and municipalities in the Netherlands are now working on this data delivery and also the data use, because also data use is compulsory, it's mandatory. And this has all given us a sort of cultural change in how to move from indirect use of data towards a really data-driven workflow and value chains. So this key registry, the BRO, has strict data standards based on international standards using architectural building blocks, and it's being documented and explicit data models. And these data models are used in the validation when the data come in our database. So, for instance, we don't have open text boxes where you can just put in text information. It's really structured data that are validated on what should be in the different parameters and different attributes that we get in. And that's has to do with stimulating the unambiguous data and speaking one language and type of data coming from the various data sources. In this domain, the ATIS and ground source heat systems, this is a very, very short, condensed view on what the data are about, parameters and attributes of the permits, parameters and attributes on the installations, for instance, the locations, and also on the wells, the depths, etc. But also the energy characteristics as showed in the example. And it's not only the system design data handed over in the application phase, but also the data of real systems. And one of the examples also is that we also keep track in the production of the volumes of water that are being extracted or injected in terms of volumes. This key registry, it was decided, having this national groundwater registry, that this groundwater registry should serve as a source for the key registry, and then developing a portal, like I showed in the example, but also facilitating the direct use of the key registry contents through all kinds of new and future-proof REST services and geo services, including feeding Inspire, the EU dataset. And this is the public use environment behind the key registry, including the potential portal that was already there. By bringing over this and imposing these data standards in the key registry, we now see that we have kind of backward imposing of these obligations and data standards and a unified way of working, not only in the key registry, but also looping back towards the NGR, the groundwater registration, but also looping back to the permitting portals in the local authority environments. So that really helps us in getting more actual and high quality data in the key registry, including the ATIS data and the ground source data. To finish off with some examples, this is an example of the amount of ATIS systems around Amsterdam. This is center of Amsterdam here with the canals, which are being registered. I need to say that we and all the various government organizations are still filling up the database and also doing work on quality control on the backlog that they have in their own systems. So it's still an ongoing process in filling and registering the data, but this is the situation of new data in the registry at this moment. And to give an example on the projection figures, this is an example here in the southern part of the center, where you see a graph of the projection figures of an ATES system, where you nicely see the fluctuating of the extraction of warm water and cold water during the times. This is a period of 2 years, where you can see the summer period where warm water is being injected, and in the winter periods, the cold water is being injected. So this is all part of the database that we are maintaining. Another example is, let's say, the dense figures on ground source heat pumps. All the individual ground source heat pumps are now registered on a house level. So you see a new residential area in the eastern part of Amsterdam is this, where all the various different ground source heat pumps, individual loops are being registered, and you can see that on the last but not least, an example of the potential application that is being sourced by the groundwater registry, where citizens and interested people can, based on given parameters on the location and the energy demands thereafter, and the actual gas price, can give a quick calculation on the restrictions, whether it's possible to deploy in a system, getting information on the solution designs and the dimensions, whether you can choose an ATES system or whether you can choose a closed loop system, and gives a rough indication on cost and also on the subsidy potential that are there for you. So that's an example of the potential application that is also available. So the main takeaway, the open door, is that these actual and complete high data sets are really a requirement for the sustainable implementation of this system. And the key to success is a robust data intake and storage value chain, starting with the local authorities until the central registration in the key registry, and underlain by the compulsory legal regime that handles the accountability of the data, the standardization of the data, and makes way for future-proof data exchange. With that, I conclude my presentation. Thank you.
Thank you very much. I'm happy to hear, even though the database is already so developed, you are still striving for more actual and higher quality data. For some, that is really admirable. And so thank you. We will discuss later. Now I would like to give word to our next speaker, Simona Adrinek from the Geological Survey of Slovenia, who will tell us more about the shallow geothermal database in Slovenia.
Thank you, Sasha. Okay, we'll see it. Yeah.
Yes.
Okay. So, yeah, first, thank you for inviting us to present our current situation about the shallow geothermal database in Slovenia. Today I'm presenting, but there is quite a lot of other people involved in the creation of this database, and I really need to point out Dusan Weiler here, because I can say that without him there is no database, and you will explore later why. Yeah, first I need to point out that Slovenia does not have any official shallow geothermal database because there is no legal framework for that. Although the one that I'll be presenting is used for the reporting to the EU about the usage of the renewables and achieving goals by our ministry, and also for the country update reports presented to the European World Geothermal Congresses. Our database is not presented in any GIS environment or viewer, as although we do not have a lot of even though we have a lot of data about the system or the unit, we don't have their coordinates. So this is why we cannot create any standard viewer. So if I go through the agenda, first I want to say something about our current shallow geothermal use. This is there. Okay. Sorry for that. So first I want to say a few words about current shallow geothermal use, which comes out of our database of the called ground source heat pump units. Then I will say something about how we set up the database and a few words about different incomplete other databases that are collected by our different ministries and are publicly available. And at the end, how our service for the increase of shallow geothermal systems, and also about one case study example about the first local thermal energy storage in Slovenia, which would not have been reported anywhere if the investor had not contacted us, for example, which is the consequence of the legislation. So for the beginning, here I show the figure where Slovenia is ranking as emerging and developing markets in ground source heat pump installations. And we are 7th among European countries based on the number of installed units per 1,000 households, which we think is quite high. And we are sure that this ranking wouldn't be possible without our database. So this is also why it is important. Tomorrow is presentation of the new EGS report, so we'll see if anything will change in this ranking. So here is
Simona, it is Stasha. So sorry to interrupt you. Now Constanze has also written. We hear you quite poorly. I don't know what is the. Can you maybe try to improve something?
Yeah, I'm sorry. I will try something.
Yeah, I don't know because it is not too quiet, but it is like it's not on echo. I don't know how to describe.
Okay, do you hear me now? It's better.
I don't know. Please speak.
Yeah, I'm really sorry.
Now it is better.
It is better. Okay. Okay. So to continue. First, just a short overview of general statistics on shallow geothermal energy use based on our database. I wouldn't go through all the numbers, but we can see that at the end of year 2024, we had more than 18,000 operating ground source heat pump units, and the number is increasing for 7% on annual basis. From the figures, we can see that the number of closed and open loop systems is quite the same, which is quite interesting compared to other EU countries where data exists, and we assume that this high number of open loop systems in Slovenia is also related to really favorable hydrogeological conditions on the most densely populated areas and also to the fact that the legislation is not so strict. One interesting thing here is also that we have a lot of horizontal closed loop systems. And we wouldn't know that if there were no database because they are so shallow that are not registered in any of our databases. Sorry, really sorry. Yeah, so if I move to the presentation of our database, so all these reported ground source heat pump numbers, also on the green color on the graph, have been collected for 30 years now, and we started to collect them already in 1995, and we've been updating it every year since 2009. First, we didn't do it each year, but then we did it for each year. Regarding the financing, at first we've been doing it voluntary. This is why it was not done on each year. And then it was under the assignment of different ministries. So between 2012 and 2022, it was done through the Ministry of Infrastructure. Then in 2023 to the Ministry of Natural Resources and Spatial Planning, and now for 2 years is under the Ministry of the Environment and Climate and Energy. And as you can see, for many years this was under the Mining Authority, but they didn't saw this task as important one anymore, so they omitted it from their plan. But we managed to keep this task under control of the Ministry of Environment, who is also in charge for the reporting of Slovenian renewable goals. And yeah, they see it as important things to do. How we are gathering the data, also important, because it is not mandatory to report for the manufacturers and sale representatives. Therefore, we are doing this manually. So calling them at the beginning of each year and asking them about their sale figures of the previous year. From 2023, we established a digital application where they can upload digitally the data about the type and the capacity of heat pump. Yeah, with that we try to avoid calling them, as it is quite time consuming, but still, as from their side, this is done still voluntary. A lot of them ignore our emails, so we still need to call them and ask them to fill in the form. At the end, we believe that we get quite good numbers, as a lot of a lot of manufacturers at the end also respond, at least about some basic data. Yeah, among these database, there are also a few others, but they are hard to compare and they are not linked between them. Our water agency, for example, have 3 different databases. One is called Licensing for Groundwater Research, that represent plant systems, but we cannot rely on this database because many of these systems are then not implemented. Then the next thing is that they have water permit database, which was created already in 2004, but is only for the open loop systems. And from 2018 on, we also have the additional database called Recorded Special Use of Water for Heat Production. This is in reality the same database as the water permit database, but in 2018 the legislation changed. So for the recorded special use, the documentation procedure now is less strict, and this is now divided into two different databases. And also one important thing is that we have one more database from 2016 on from our environmental public fund, that Eco Fund, that offers financial incentives such as soft loans and grants for different environmental investment projects. This means that here are collected only the systems, so open and closed loop, that applied and get support and get grant, which is good because here they collect also the coordinates, so we can do also spatial analysis. And we believe that in the future, this database will also increase a lot, and also the number of the systems in general, because from October 2024, they even increased the subsidy amount. So yeah, and on the figure below, I just wanted to show you one of our comparisons that we did in the past. Here we compare the numbers of the reported groundwater heat pumps and ground-coupled heat pumps in different databases. The name sales figures here means, so this is our database, the one I'm presenting today. And we can see that the number in the same data collection interval deviates quite a lot. The numbers of sales figures are always higher, which is for sure the influence also of changing old heat pumps with a new one. But we believe that this number is still too high, which indicates that a lot of installed systems or installed units is in reality illegal, and they don't have the permits, because at least for groundwater heat pumps, the numbers between, for example, sales figures and water rights should be at least similar, but they are not. Yeah. But for the ground-coupled heat pump systems, so closed-loop systems, we in reality don't have anything to compare, because it's not collected by our water agency. Yeah, and as a part of the same study in the past, we also wanted to see the spatial distribution of these systems, how well they correlate with our natural conditions. So we use the EcoFund database because it has the information about both types of the system and also have coordinates. So we compare them and put it on our basic geological and hydrogeological map. And we believe that the distribution pattern is more or less correct, although the number of systems is lower than in reality. Yeah, and we can see the output here on the figures. The output is quite expected. Of course, we can see that, for example, the groundwater heat pumps are mainly in sedimentary basins, which are at the same time also our biggest intergranular aquifers. And also this distribution pattern follows the population density in Slovenia, which is also visible on the right up corner. Yeah, while closed loop systems on the other side are also found elsewhere, so where are not bigger aquifers found. Yeah, then besides supporting our ministry with gathering the data about the systems, our survey also tried to support the increase of ground source heat pumps with different tests. For example, each year we are doing new temperature profile measurements to update then our temperature maps. Everything is then freely available at our portal on the link below. And there are many other maps related to geothermal. With that, we want to put as much as possible information to the public so that they could do dimensioning of the systems as most efficient as possible. Yeah, we are also, yeah. So my colleagues also prepared the map of thermal conductivity of rocks and sediments a few years ago based on our thermal conductivity database, for which we hope that could be the future basis also for the Slovenian standard of thermal properties. Also, all the measurements are publicly available in the paper, and we are also updating it frequently and try to put it publicly as available as soon as possible. Then, yeah, despite laboratory measurements that we are also doing to support the increase of the systems, we are also doing field tests, analytical numerical modeling of groundwater flow and heat transfer in different softwares, which is really important in case of bigger systems. But due to the increasing number of all the systems, the importance of established shallow geothermal database will become even important here, as management of underground infrastructure will become quite necessary in the future. And with database and corresponding models that we are doing, of course, including all other thermal sources in the underground, researchers could help the licensing authorities with that. So we really try to do our best to support our ministry also with the other tasks. Then, for the end, I wanted to present also our first borehole thermal energy storage in Slovenia, which was financed and developed actually by some private Slovenian company. They drilled 55 borehole heat exchangers with a depth of 26 meters, and they inject heat from the solar panels in the summertime and use it in the wintertime. And company also said that they plan to establish even more systems in the future. Why I'm explaining that here is that is because these systems are not registered in any of the mentioned databases, as due to our legislation, they do not need to do any reporting because the wells are, let's say, too shallow for reporting. So we only know for this system because they contacted us, and we are really happy for that. And we hope that in the future we could also put this in some official registries. And for the takeaway message, here everything is quite summed up. We believe that our database is quite good compared to some other countries, but still a lot more could be done to improve it. One main thing is the importance of the intersectoral cooperation to avoid losing important data. Because we have multiple incomplete databases, for example, ours is without coordinates. They also have the same systems, but with the coordinates and maybe some other data. And it would be really good that at some point we could join it. One thing is also to make this reporting of the salt heat pumps voluntary, from voluntary to mandatory, but only with the basic information so that this reporting won't take a lot of time for the sales agents, but would be important for the Slovenia as a country, of course. We also have a lot of frameworks established how we could join this database. For example, we created in the scope of InfoGeothermal project the geological survey. We established a viewer with the publicly available data regarding deep geothermal. A lot of information about the deep wells in southeastern Slovenia is included. All the geophysical research done with the geothermal layers, and this is quite a good framework, we believe, also for the shallow geothermal in the future, possibly. Yeah, also for reporting the achieved renewables, our ministries often use statistical calculations and predictions, which is good, but reported raw data collected in one place is more precise and should be a priority at the end. So we are still trying to do our best. And yeah, due to the increasing number of systems, also in urban areas, yeah, the management of underground infrastructure will be important to ensure the efficiency of the systems. And here again, a good database is crucial and a key step, of course, towards the sustainable use of shallow geothermal. Thank you. And sorry for the mess.
Thank you very much. But due to some technical problems, we are now quite late in time, so there is no time for questions at this moment. I hope we will have time for some small discussion in the end. I would like to finalize this presentation section with Cornelia Steiner's presentation about the European perspective on inventories of shallow geothermal installations. Please, Cornelia.
Well, thank you very much, Stasha. We have heard some very interesting talks already, and I'm happy to present to you now the results of the GeoBOOST project. So I am from Geosphere Austria, the Geological Survey of Austria, but today speaking on behalf of the GeoBOOST projects. I will tell you very briefly about the project and then dive into what we see as motivation for such geothermal heat pump registries that we talked about today, and our recommendations about what kind of content should go into an extensive registry for these installations. So in GeoBOOST, we have a consortium of different project partners, starting from university to geological surveys, heat pump organizations, but also drilling and planning companies. So we really have a good broad expertise on shallow geothermal energy. And with that consortium, until the end of this year, we want to improve the statistical data and market numbers for geothermal heat pumps. These are the results, or the main results, what I will present to you today. Everything is compiled here under the report D2.2. You can find it on our project homepage. I think the webpage is stated in the end of this presentation, where you can also find reports on life cycle cost analysis, and coming up by the end of this year is an affordability evaluation. We have also a toolkit for regulatory framework developed, and another goal of our project is to increase the awareness of the geothermal heat pumps, but this is also kind of dealing with the registries, as we heard today, that such a registry really helps to increase the awareness of this technology. Last but not least, we also deal with education and training. And here I really want to tell you that we have a free online course on shallow geothermal energy coming up. It starts by the 15th of September. It's a 6-week course with 5 different modules. It's all online with short videos that are held by our renowned experts of the consortium, given in English, but with the ability to listen to it or to read multilingual subtitles, with a broad variety of the target groups. And the content is really a broad overview, more or less, of everything. We start off with some geothermal fundamentals, and then really dive into the efficiency strategies for the buildings. And in specific modules, we focus on the different technologies, where we go from the geological preconditions all the way over from planning, licensing, monitoring, depending on what you have to consider for these different technologies. So again, the course starts on the 15th of September. It will be held on the platform of UPV-X, that's the University of Valencia. The course should appear on this webpage by the beginning of August, so check back by then to sign up for this course. And of course, feel free to invite anybody who could be interested in becoming an expert on shallow geothermal energy with this course. Okay, but now back to our topic of today, the central registries for geothermal heat pumps. We see as a goal of such a registry to have it available at least regional, if not national. Should be a comprehensive database, complete, and of course updated, and ideally freely available. And why do we think this is important? Because with this data, we can really analyze the growth of the renewables. If we don't have any data about it, we cannot really say how good we are with our effort to decarbonize our countries. But if we keep good track of these registries, we can analyze that in more depth. We can also analyze the market in more detail. You see here, for example, the mean borehole heat exchanger depth changing over the years, which is also a good indicator for all drilling companies, manufacturers, to see how these things are changing. And so you need, of course, the data about the depth of the borehole heat exchanger to be able to make such analyses. And then it's also very important to have the information of the location of the systems and also the produced energy to be able to use this in a thermal interference analysis for future projects to ensure that this is all used in a sustainable way and that we can really keep using the underground or especially the groundwater for these purposes on a longer time without the systems affecting each other. And last but not least, we also gain hydrogeological data every time we drill into the ground for our new systems. And this then can also be used directly in these registries to provide this for planning purposes of the new installations. And by all that, again, we can increase the visibility of geothermal energy. And with these goals in mind, we started to design a simple table that includes all the parameters that we think are important to be documented for each geothermal heat pump installations. And we want to show this and provide this data in a format that is ready for further analysis. And to do that, we provide separate templates for the different geothermal heat pump types. So we included borehole heat exchangers, the open systems, horizontal systems, and thermally activated foundations. Today, I will only briefly present to you what we think is important for the borehole heat exchangers and the open systems. So for those two systems, we have two versions actually to make it a little bit complicated. One version focuses on the boreholes. So this gives individual entries for each borehole or well of the system, making this very detailed, but with the coordinates of each of the well, this can be then used directly, for example, for planning of the future installations. And another version would be to have this more system related, where you have a summary of the whole system, then correlated only to one coordinate, one location. Okay, so let's have a quick look on how such an registry could look like for the open systems. Here, looking at the components on the component-focused version, where we have for each well all the information. So of course, you need some information about the installation itself. That's what we see here. So this means a system ID, the name of the installation, the status, whether it's in operation or cancelled, the number of heat pumps, and then already going into the production of the system, the kilowatt, megawatt hours per year, and the running hours. All of this has to be then provided, of course, for heating and cooling separately, and a very quick overview given by the mode, where you can indicate whether this is used for heating, cooling, or for both. And then some additional information, for example, whether a pumping test has been performed here, and which type of or name of the aquifer that is used here. And then the second part would be focused on each of the wells. So for each well, we have a well ID, the type of the well, whether it's extraction or injection well, which water is affected, because sometimes we don't only use groundwater, but there can also be surface water included, or the sewage system for injection. And to be able to differentiate these systems a bit better, it helps to have this information here too. Then, of course, the coordinates, the geometry of the well, meaning the depth, the top and bottom elevation, and the diameter. And then we would have the licensed flow rates and the average temperature, as well as the injection temperature, both for heating and for cooling. And if this is too complicated, then you could also combine this into one entry for the system, where you have the information of the two wells kind of combined into one, but stating the number of the wells, again the involved waters, and then given average depth information and average flow rate information for extraction and for injection of the system. Okay. And then let's have a look at the borehole heat exchanger entry. We can have this again focused on the components, so the boreholes. If you have larger borehole fields, this is of course a little bit detailed with all the boreholes. But let's start with the installation information at the beginning. We have again system ID, name, the commissioning date, status, number of heat pumps, and then again the production data of kilowatt, megawatt hours per year, and running hours, and the operation mode. Here it would be also beneficial to have some additional information about what type of fluid is used in the boreholes, if a TRT has been done, and if a numerical simulation has been done. And then we come to each of the borehole, where we have here the borehole ID again, the coordinates, depth, diameter, the distance between the boreholes, and also information about the probe, so the material, diameter, and type, and also information about the backfilling, what material was used there, and what was the thermal conductivity of this. So this is it for each of the boreholes, and if you want to look at the whole system, you can again just state the number of boreholes and an average information about the depth, etc. So our recommendation would be to go for the more detailed information, to have everything in detail, all the boreholes. Maybe for the very large borehole systems, it makes sense to combine them, to not have them all, because it would be a great effort to do this one by one. Yeah. So we have this template ready, accompanied by a report. Feel free to check it out. And finally, I can also report that we managed to get this actually fully implemented already. So the federal state of Burgenland of Austria, they actually approached us and they are interested in using our suggestions here. And they, within a year, they implemented it fully in their database. So the suggestion that we made here is actually in operation already in Burgenland. That actually makes us very proud that with the work we've done here, we could already improve the registration process or the registration information in one area of Austria. So that was a very quick overview of what we did, and I hope you still have time for some questions also to the other presenters, because we had some very great talks, and I would be interested in discussing that with you. Thank you.
Thank you very much, Cornelia. And this is really nice that even though the project is not even finished, already there is one implementation in practice. Really nice to hear. So please, obviously, the colleagues from EuroGeoSurveys have not disconnected us at 1700 hours. Thank them for that. And please, we are open for questions for all our speakers.
Well, then I will start because
Okay,
I
please.
have some questions. I would like to start with Erik. So you really said that there was a shift in the paradigm, more or less, also within the authorities, because how I understood it, they are very much in charge of keeping this system running. To me, this sounds like a very interesting and hard process to achieve that. And I am wondering what helped the most to drive this change, and also how was this, or how is this financed? Because if I would propose such a thing to our authorities, the first thing that I would hear would be, we don't have the money or the manpower to do it. So I'm very curious to hear how you have managed that.
A good question. The first thing as an answer comes to my mind is patience, and realizing that this is a time-consuming process. That's also why I show the community. It's really a change in cultural, in I would say behavior, in the awareness that we're working towards a more sustainable society and a sustainable urban environment, and also the land environment. And that's actually what, let's say, the the motto of the whole key registry is about. And that's how it was sold in the beginning, in broad sense. It's part of the whole system of key registries, not only for subsurface data, but also for topographical data, housing data, addresses, etc. We have a whole system of interlinked registries, which have a big strategy behind it from the central government, and that's being imposed on the several decentral governmental bodies like the provinces and the municipalities. And it's sometimes hard working in, let's say, convincing people that this is the right way to go, because everyone has its own things to do and has no money. So that's why I came up with patience. It's really selling the idea of when we start doing and when we start literally at the foundation of the work, bringing the data in a good manner towards the society, then in the end, that's a long way to go. In the end, we have our benefits from that. And that's a team-wise, a thing that we're doing not only as a geological survey, but with a lot of partners, a lot of ministries. So it's, I think, patience and convinced cooperation, I think, is the bottom line to that. I don't know if that's sufficient in your mind, because we know all kinds of holding back kind of ways of reaction that we had. So I recognize exactly what you mean by I don't know whether we'll succeed in that, but I think it's a matter of having, from a central point of view, central governments having a sort of strategy and vision that helps us.
Yeah, so having the central government on board,
yeah,
is crucial.
It started with them. It started with the central sort of ministry of first it was internal affairs. Is now it's being headed over to the Ministry of Planning, Urban Housing and Planning, and they started off the idea and the wish to make this data foundation, and that really there were already all sorts of market calculations, of course, business, whether this is a business case that will work, but that is really something for the longer term, so to speak. So it's also envision the horizon and not, let's say, think of the first 2 or 3 years, because then you know that's not.
Yeah. So in the end, nothing without the central government.
Yeah.
No, I agree. We hear also that in Slovenia it was funded by central government, by different ministries, like in the Netherlands. But yes, clearly it comes from the central government. Thank you very much. Do we have more questions for the speakers?
Yes, Sasha, please.
Please.
Cornelia, what is the experience with the measurement of efficiency of the heat pump systems in Austria? Do you practice the measurement of deliver energy and consumption energy and so on?
Not in a central database, unfortunately. So in our central database, we only have the pumped, so the flow rates for the open systems, and there is some information about the aimed produced energy in each of the license, but not all content of the license is put in this digital database.
Okay, but what is the situation with practice? What is the situation in real operation on the sites?
On the site, that really depends on the operation. So there are some operators who really monitor it very closely to improve the efficiency of the systems, but I'm sure others are not monitored that carefully. So it really depends on the owner or operator of the system.
Okay, thank you. But I would consider this very important point of the ground source heat pump technology, and also for all heat pumps. Thank you.
Yes.
Thank you very much. If I may have one question for Simona.
Yes.
Hi. Regarding the discrepancy with the groundwater heat pumps, that let's say, okay, I wrote down the data for 1 year, one period that you showed, but it doesn't matter. Discrepancy is everywhere between number of water permits, 1,300, and then 2,100 sold units. So it is a difference of plus 60%. When you reported this data, because I see it's like in a published article, right? If I understand.
Yes. Yeah.
So did you try to report this to water authorities? And if yes, did you get any reaction? Because this is really, really huge difference. So a lot of illegal wells.
Yeah, that's true. But no, we didn't report that to the authorities. But I think that is a well-known fact that there is a lot of wells that don't have permits. But yeah, the ministries don't know how to deal with it. Of course, they don't have manpower, etc. Yeah.
I understand.
That's all.
It is like
Yeah,
that
I
also
can
in
say.
Croatia. I am just, I know we have also this problem, so I thought maybe you came up with some solution, but obviously that is not the case. Yeah, really, also in Croatia, we encounter this
Unfortunately,
all the
yeah.
time. Yes, it is not normal, but no one is finding countermeasures. I mean, the authorities who have the possibility to do that. Thank
In
you.
Austria, just a
Sorry,
comment
please.
on that regard, because in Austria I did the same thing to compare the sold water heat pumps with the registered numbers, and even if I would say we have a pretty good licensing system for the open loop systems in Austria, but I did see a difference in those numbers too. It was not 60%, I don't know how high, but it was definitely there. And also a reason could also be because some of the systems are not strictly water to water heat pumps, but water to brine heat pumps if they have an additional circuit of the fluid. So some of these heat pumps that are groundwater heat pumps might be actually under the brine water heat pumps. At least that is a little bit the case in Austria. And yeah, as you also mentioned, Simona, the case with the renewable of the heat pumps, where you don't have a new system for a sold heat pump, but you just replace an existing system, that's also not reflected in those numbers here. So yeah, it's really difficult to compare these numbers, and I think that really shows how important it is to have registries of the actual installations and not fully rely on the sold heat pumps. Maybe Ignasi, you want to add something here?
Yes, it's a general comment. Probably, I'm pretty sure that all of us are agreed that official registering is very important for the market. But I believe that making registration mandatory at European level would be the most efficient way to ensure its, I would say, widespread adaptation. It's true that regional or national initiatives are valuable, but what is really missing is a binding requirement at European scale. But the other thing is that if this would be mandatory, then the countries should facilitate the implementation, of course, more than now. Yeah.
Thank you for this comment, Ignasi. I couldn't agree more. I'm very happy to see that in many countries the registers are already very advanced. I am sad to hear that we are not Croatia among these countries, but heads up, colleagues have started through the PLIGES project. We must continue, and obviously by engaging central government or the EU. Is there any more questions?
Stasha, please, just short question for Simona.
Of course.
Simona, could you tell what is the reason because your heat pump installation numbers are very competitive? Regarding Croatia, you have implemented a much number of ground source heat pump. I know that you have subsidies from government. What is the other reasons because your ground source heat pump technology is on the top level regarding number of units?
Yeah. Well, one thing is that we have a lot of open loop systems. For example, at least in southeastern Slovenia, and this is also related to really favorable hydrogeological conditions. There, for example, groundwater level is 3 meters below the ground, which is really shallow. So the overall installation of the system, drilling and everything, is really not expensive. And also drillers itself, I would say, do a lot in the promoting this kind of system. So open, but also closed loops, of course, systems. So this is also one thing for sure. So one are good natural condition, one thing are drillers, and yeah, and also the good database. Probably also in Croatia there is more systems, I would say, but you just don't know about them. Yeah.
We
You have the feeling that there's no systems, yeah, but in reality there's different situation.
We have good cooperation with many companies and drillers and so on, and we know the yearly heat pump installation numbers, and the
Okay.
situation isn't on the level as in Slovenia. Thank you.
Thank you, Simona. Yasin?
Sorry. Hi. I'm from Slovenia also. I'm coming from a sales company. We supply heat pumps and we specialize in ground source. And I can respond to Vladimir. It's a lot of work that's been done with designers. That's one thing. We have a couple of companies beside us who are very active in the ground source. And we work a lot with designers and installers to promote the technology. And as Simona said, also we have some drillers who are very eager to work and to drill. So these are the forces that help promoting the technology, because in the end the user would always go for the cheaper option for the air source. Then we don't want that, especially in the large buildings. So I think in a country like Croatia, it's still a lot to be done to improve. The other thing was my suggestion would be for the database which is being collected. Very important thing for us who dimension the loops and who dimension the systems would be a database of profile. So not only of heat pumps which are installed, but also of the ground profile. If I don't know if any other country, I saw it in Sweden, at least in Sweden, they always collect the distance to the bedrock. And this is kind of interesting information for people who work with heat pumps, because at least then you can know what to expect if you are drilling in some radius around some existing boreholes. And would be good to have such information, especially with more and more heat pumps being installed every year. So that's my comment. Thank you.
Thank you, Yasin. But in Slovenia, you have a great support of government regarding geothermal systems. We don't have it in Croatia.
You don't have subsidies which are higher for ground source. No. Yeah, that's partial reason. However, until last year, the subsidy was not that much higher. For example, for a domestic installation, it's still the ground source was still like 2 times more expensive than the air source. Now the subsidy is a little bit higher, so it helps a little. But as I see it, the major factor is working with designers and installers to make this technology more attractive and make people less afraid of it, because people who don't know, they are just afraid and they don't want to deal with it. They just put an air source and that's it. Also the designers, we work with them a lot, and they just, if they can rely on us to draw the connections, draw the boreholes, do all the calculations, that's okay, but otherwise they will not do it.
Thank you, Yassin.
Yeah, thank you.
Thank you. I just wanted to comment on your question that you would be interested in knowing what is the depth to bedrock. I think that many of these databases that the colleagues were showing, they include the data on let's say, geological situation in the boreholes that are in the map. Certainly the one that colleague from the Netherlands presented, I didn't understand for Slovenia, but I also understood for Catalonia, that people, that this data is being
they collected. Sorry, I missed the first.
If I understood well.
Yeah. Sorry, I missed the first presentation. So
no problem. And also, I think that Denmark has one such database.
That's very useful. I hope in Slovenia, Simona will and Dusan will start collecting also that. We really push all the customers to make the permit. That's also, I'm referring to Simona when she was telling about this, and you were asking about the discrepancy. The customers who install a heat pump, they usually, if it's a groundwater heat pump, they have the idea to skip the permit. So it's a lot on our side as a salespeople who have to persuade the customers to make the permit or to avoid doing the installation without the necessary permits, because people are afraid, at least here, Slovenia, probably in the Balkans, we have the same mentality that the government will take something from us if we report. People are afraid if they make the permit in the future, they will have to pay something to the government. So that's the main reason why they avoid.
Yeah, of course, that is the standard problem. I see we have the answer from colleague River from Slovenia. Please, Dusan. Dusan, you wanted to comment, respond?
Dusan, you're muted if you try to talk. We do not hear you.
Yeah, I don't know. Can you hear me, Cornelia?
I can hear you, yes.
Okay, yes, I already thought that. Okay, maybe he raised the hand by accident. Any more questions or comments?
Yeah, I have one for Ignasi. In the beginning, you mentioned a building database where you have information on the heating systems, if I'm not wrong, for the whole country of Spain. So is then how is geothermal included in this database, or is it at all implemented here already?
No, what I have mentioned is that since 2021, the Institute of Diversification and Energy in Spain, which is an organization that deals with implementation of renewable energies in the whole countries, compile data and publish statistics from all the regions. But I think that this data comes from different sources. For example, in Catalonia, I guess that it comes from our data, but from other regions, I'm not sure. Maybe it's possible that some of the information are estimations, basically, but I'm not sure. What I know is what is in Catalonia, but not in the rest of Spain. I'm sorry.
Okay, thank you. I like the graphics, by the way, for Catalonia. That's pretty great to have an analysis of the whole region already. So I think that's also very useful to really show the numbers in a more good visible way. So I like that.
Thank you very much.
Thank you very much. So let me just ask Dusan. Okay, it seems like this is a mistake. If there are no more questions at this time, I think we can conclude our session, especially looking at the time, because we have really went into overtime. I'm sorry for that. We had some technical difficulties, but on the other hand, obviously there was need for a little bit of discussion in the end. Thank you very much for attending, also to those who had to leave us earlier, and hope to see you in one of our next webinars. Have a nice afternoon and evening.
Thank you very much. Bye bye.